Okay, this is the second video. Let's get to it. Use an integer to represent. So again, the questions are the same. We just switch some numbers around, just so you have some more practice. So 1 up for floors. You want to represent that with the following integer, which is +4 or just 4. What 0 represents here, it would be that in this case you don't go up. You're not on the ground floor. It just means that 0. If it's 0, you don't go up. Let me just write that. Don't go up, and your floor is right. You stay where you are. That's what I should have written. Just stay where you are. $80 in debt means you owe someone $80, right? So at $0, you mean you have no debt. You don't owe anything. Score 12 points, +12. I'll put the positive this time. And 0 would means you score nothing. You score 0 points. 0 points. And gain 12 pounds means +12. And the 0 means you gain nothing. You didn't get any chubbier. You gain 0 pounds. All right, maybe you're just okay. Find the value of each expression. Okay, so absolute value 15, again, what does it mean? It means how far is 15, right? How far is 15 away from 0? It's 15 units. And because distance can't be 0, the answer is just 15. You're 15 units, rather say units instead, but you're 15 units away from 0. All right, over here, there is a minus sign outside the absolute value symbol. Okay, we're going to leave that there. I'm going to take the absolute value of -2, and the absolute value of -2 is 2. So this eventually becomes -2. Okay, you can't throw this guy out. Absolute value of -7 minus the absolute value of -7. Well, let's find the absolute values first before we find the difference. Absolute value of -7 is 7, minus the absolute value of -7, which is also 7. And now I can subtract both, and I get 0. This actually reads 2 times the absolute value of -3 minus 4 times the absolute value of 5. So 2 times the absolute value of -23 is 23, minus 4 times the absolute value of 5, which is 5. Right? Now I can multiply these two. Don't subtract anything yet. Order of operation dictates that you should multiply these two first. So 2 times 23 is 46. Minus 4 times 5 is 20. Now you can subtract and you get 26. Determine if the numbers are counting, whole, integer, or rational. Name all the sets that each number belongs to. So in this case, we're talking with 0. Where does 0? Well, 0 doesn't belong to the counting set, right? Remember the counting numbers initially did not have 0. It was 1, 2, 3, 4, 5, 6, and on and on. So 0 does not belong to counting, but definitely belongs to the whole integer group. It is also an integer, right? Remember, the integers are all your positive whole numbers and your negatives. And it's a rational number. 374, it is a counting number. It is a whole number. It is an integer, and it's also rational. Okay, so forgive my handwriting. -0.6 with a little thing on top, which indicates that it's a repeating decimal, right? If you were to, this decimal would go on forever and ever, but it repeats, and because it repeats, it's a rational. If it didn't repeat, it would be irrational, but it does repeat. 9/765, it's not a counting number, of course. It's not a whole, it's not an integer, but it definitely is rational. Okay? Place the rational numbers on a number line, 2 points. So create a number line and be mindful of what numbers you use. Okay, so if you don't need them, I wouldn't put them. So it definitely looks like on the positive side, the biggest number is going to be these two, right? So I need something on the positive side that goes at least, well, 1, 2, and it's going to go beyond 2. So I'll put a 3 because these two numbers are going to be between 2 and 3. On the negative side, I'm going to go -1. Well, yeah, I'm going to need it. And -2. And I'll put -3 just to make it even. I won't need this area because there's nothing in between, but I'll need the other two. So let's do the easy ones. The easy ones will be, for me, the decimals. +2 0.02. So think of it as money when it's decimal. So here's you have $2.02. So well, here's a dollar. Here's two. Here's $3. Here's $2.50 in the middle. So $2.02 should be right here next to the 2. That's $2.02. 2 1/8. Well, I'm going to leave the fractions to later. So let me take care of all the decimals. This is gone. This is negative 0.3. So if you ignore the negative for a second, that says 3 cents. 3 cents would be right here, next to the 0, 3 pennies. But I don't want 3 cents, right, positive. I want the negative. So if this is 3 cents, its opposite, which is negative 3 cents, should be on the same, same distance away from 0, but just on the negative side. So here is negative 0.03. So sometimes it helps knowing where your opposites are. Okay, so here is where negative 0.03 is. Negative 0.88. So 0.88. Okay, again, let me take this out. That's 88 cents. 88 cents would be between 0 and 1, right? But closer to 1. So here's 0 cents. Here's 50 cents, 60, 70. So 88 positive would be right about here. But I don't want 88 positive, I want 88 negative. And 88 negative is going to be on the same distance away from 0, but just on the other side. So about here. Here's your negative 0.88. So you can use that trick to find negative numbers. Okay, pretty sure you can find positive numbers. Just find the positive numbers and then locate the negative on the other side, exactly equally distant away from 0. So here's 0, negative 0.88. This is gone. This is gone. Negative 1 1/8. So it's going to be, so think of a chocolate bar. You have a whole chocolate bar, which is your 1, and then 1/8 of the other one. So you know it's going to be 1 and a little bit. So, but you just don't know what that little bit is. If you don't know, well, you can approximate. But if you want to really get close, you can divide, change 1/8 to a decimal. So you're going to divide the 1 by 8. 8 is not going to 1, so we're going to add our decimals here. 8 goes into 10 one time. You get 2 left over. Add a 0, bring it down. 8 goes into 20 2 times. That would be 16. 4 left over. And because I'm not asking for the exact value here, we can approximate. So 0.12 is equal to 1/8. So this is going to be 1 point, and we'll add the decimal part here. 12. So negative 1 and negative 1.12. So negative 1.12 should be, well, here's 0, here's negative 1, here's negative 1.5. Negative 1.12 should be very close to negative 1, just about here. Negative 1.12. Okay. And finally, we have negative 2 1/8. Well, we already did the 1/8, right? We know what 1/8 is, so it's going to be 2 point, and the 1/8 part is going to be 12, right? 2.12. So $2.12. Here's $0, 50 cents, $1, $1.50, $2. We know that this is $2.02. So $2.12 should be just a little bit more than $2.02. So there is our number. Now, if you look at it on number line, our numbers are ordered from least to greatest, going from left to right. Our smallest number, second smallest, third smallest, 2.02, and finally a 2.12. And you notice as you go right, the more right you go, the bigger the number gets. And likewise, on the reverse side, the more left you go, the smaller your number gets. Okay? 5 says compare the rational numbers. So here we're comparing. And negative 4 7th and negative 7 12. So 2 ways, and I think you pick whatever you're more comfortable with. So here you have 2 fractions, right? Negative 4 7th, and you can change both to decimals. If you're more comfortable, you can find an LCM, right? Change both fractions so that they have the same common denominator. In this case, the common denominator between 7 and 12, let's say it's 84. 84. So this is going to change. So 7 times 12 changes to 84. So 4 times 12. So the new numerator is going to be 48. 12 times 7 is 84. So times 7 times 7. So that's going to give us 49. They're both negative and negative. So now, if that still doesn't help you, well, with negative numbers, what you do know is the bigger the number, the smaller its value, right? So if you knew that, you can definitely know that 48 over 84 is greater than 49 over 84. But if you still don't know that, I'm going to draw a number line. Not only my positives, I'm going to make this 0, I'm going to make this 1. So imagine something that was cut up in 84 pieces, right? Here's my whole one bar. It's cut up in 84 tiny, tiny little pieces. And you've got 48 out of the 84 pieces, right? So, I don't know, let's eat pizza. It's a bad example, but if you had a whole pizza and you cut into 84 tiny slices, here you would have 48 out of the 84, and here we have 49 84. So here's 0. As you're going over here, that's one little slice, 2. So 48 over 84 is a little bit more than half, so it would be about here. Negative. 49 over 84 would be right next to it. Negative 49 and 84. So on the number line, who's on the right side? This guy is 48 over 84, which, right, it's close to the right. Not closer to 0, but to the right. The number on the right will always be bigger. So because 48 over 84 is to the right, 48 over 84 is bigger than 49 over 84. Okay. Next one, let's do this. Absolute value of negative 10, there's a minus sign over there. So let's leave the minus sign here. And absolute value of negative 10 is 10, so that's going to become negative 10, sorry. And this 7 just stays. Now we can compare, is negative 10 greater than 7? It's definitely not. It's smaller, so that goes that way. Negative 98, negative 95. Okay, so again, here's your number line. Here's 0. Here is, I don't know, 100. Negative 98 would be, negative 100. So negative 98 would be close to 100, right? And negative 95 would be close to 100, but a little bit to the right. If you look at both numbers, who's on the right? Negative 95 is, right? It's to the right. So that makes it the bigger number. So negative 98 is less than negative 95. So, guys, with negatives, it's backwards, okay? The bigger the number, the smaller it is, okay? 2.00003 and 0. So do they have the same number of decimal places? 1, 2, 3, 4. 1, 2, 3, 4. So I'm going to actually write it like this. And the other one I'm going to write right under it, decimal under decimal, 0, 0, 3, 1. So when comparing, well, we can't compare the 2's because they're tied. So the 2's and 2's, they're tied. The first 0 and the first 0, they're tied. The second 0, they're tied. But when you get to the third 0, this is a 0, this is a 3. So which makes this, right? 3 is bigger than that 0. So this number here is the bigger one, 20031. So if that's the bigger one, 2.003 is less than 2.0031. Negative 2.9 and negative 2 and 9/10. Actually, this one's a little tricky because negative 9 over 10. So how do we change that to a fraction? You can change this actually either way. You can either change it to a fraction or decimal. But I would definitely do this as a decimal. Negative 2.9 as a fraction, it would be negative 2, and 9 is in the tens place, right? So that would make a fraction, with a 10 being the denominator, and 9 goes on top. So if you notice that 2.9 and negative 2.9 is actually equal to each other, just written in a different form. Okay. And negative 67 and negative 67.01. Well, who's closer? Who's on the right, I should say? Who's more on the right? Negative 67 or negative 67.1? So let's draw a number line. Here's 0, 10, 20, 30, 40, 50. Sorry, negative 10, negative 20, negative 30, negative 40, as I'm counting, right? Negative 50, negative 60, and then I'm going to go negative 61, 62, 63, 64, 65, 66. Negative 67 apparently is here. Negative 67.01 will be really, really close and be right on that side. Negative 67.01. So who's on the right? Negative 67 is, which makes this the bigger number. Okay. The temperature on Friday was a cold 9 degrees. On Saturday, temperature dropped 14 and then went back up by 7. What was the temperature Sunday? So again, we're doing the same question with different numbers. So I like the thermometer if you want to draw the thermometer. Okay, so I want 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, negative 1. Let's see if that's enough. So I'll put my numbers. 6, 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. So you're at what temperature? You're at 9, and it dropped out 14. So from 9, it drops 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So Friday was 9. Saturday, it dropped 14, so it went all the way to negative 5. And on Sunday, the temperature got a little warmer, and from negative 5, it went back up 7. So from negative 5, 1, 2, 3, 4, 5, 6, 7. So on Sunday, it was a warm 2 degrees. Okay, so all that should be in your explanation. And is there more? Yes, there is more. Okay, so let's create a number line. So the first thing, it's 2 points. If you don't put that arrow on each side, you will lose a point. Okay, that arrow indicates that the number line goes on and on both sides. Draw a number line. Again, it's negative 0.7 and negative 0.8, so we know we don't need any of the positive numbers. So I'm going to draw 0. They're both numbers. Both of these numbers are between 0 and negative 1, right? So, actually, you don't. Well, let me take care of this. So, in case you're confused, I'm drawing. I'm going to do it this way. So, 0, here's 0. Right in the middle of 0, negative 1 is negative 0.5, right? So, 0, negative 10, negative 20, negative 30, negative 40, negative 50. And again, if you'd like to add a 0 here, just to make things a little bit easier for you, understand that it does make you understand a little better. Think of it money, 2 decimal places, doesn't change the value, right? 50 cents, negative 0.60 cents, negative 0.70 cents, negative 0.080 cents, and negative 0.090 cents. Now I know here are my 2 numbers, so if I'm going to draw another number line. I'm going to ignore everything, and I'm just going to concentrate on this area right here. So here is, right, a 0.70, negative 0.80. Right, so I took this space right here, and I made it bigger. Okay, you don't have to do it. I just did the bigger number line there, just so that it's easier for you to locate the section that we want to concentrate. So I'm asking you to focus on this area between negative 0.70 and negative 0.80. So I want you to come up with 3 numbers that exist between them. Well, it shouldn't be that difficult. Maybe the easy one would be the number right in the middle. What's between 70 cents and 80 cents? Would be negative 75 cents. That's in the middle. So that's one number. Another number. What's right after 70? Well, right after 70, right here, should be negative 0.71 cents. Another number you can come up, right? What's before 80? 79 cents, sorry. Negative 0.79 cents. So you can do 0.78, 77. So there's an infinite number of numbers that you can put between these 2 numbers. But I'm just giving you the 3 easiest ones. Okay? Number 8. The absolute value of a number is always equal to that number. Is the statement always, never, or sometimes true? Well, let's see. Let me take a positive number. The absolute value of 5 is 5. So are these 2 numbers the same? Yes. So far, that statement that the absolute value of a number is always equal, that number is true. What if I take an absolute value of a negative number? Absolute value of negative 2. What's the absolute value of negative 2? It's 2. So are these 2 numbers the same? No. So right away, I can now tell that the absolute value of that number is not always equal to that number, because in this case, This was a 2 positive, this was a 2 negative, so they're not the same. On the top, yes, on the bottom, no. So it's definitely not always true. Is it never? No, it's not never, because sometimes they are equal, so that's out. My answer would be sometimes. So it is sometimes true. So I will put a word here, and here is your word for your quiz, which is going to be what you're listening to in the background. No idea what you're listening to. Oh, that's what you're listening to. So here is your bonus point. I use sweep for, you know what? Why am I complicating this? Here you go. You're listening to Bach, cello, suite number 1. That's the name of the song you're listening to. Okay? Here's your composer. Move on. Let's put the following integers from least to greatest. Okay, so you can use a number line if you like. Put all the numbers on the number line, and then it will detail which one is the smallest. You can clearly see, or understand that from least. So we're looking for the biggest integer. The greater the integer on the negative side, the smallest its value. So the integer on the number line that's going to be all the way to the left, most to the left, is going to be negative 11. And then it's going to be negative 9, right? So if you're walking from left to right, you're going to hit number 11, negative 11 first, negative 9, then you would hit negative 5, then you would hit negative 4. As you're walking, you would hit 0, and finally, you would hit 11. So from least to greatest, that way. The number on the right is always bigger. Okay? Okay, again, I'm going to stress this part here. I need you to change this. So you write the decimal equivalent, except for the 7 there. 7 is going to be tough. Write the decimal equivalent to the following fractions. If it is a repeating decimal, use a bar notation on the number that repeats. If it is not, round to the nearest hundred. So you're going to take some time to divide this. Okay, so 1 over 8. I'll just do a couple. So 1 over 8. So the 1 goes inside, the 8 goes outside is your divisor. So 8 does not go into 1, so you add a 0. 8 goes into 10 one time, right? Bring a 2 down. 8 goes in, let's bring a 0. 8 goes into 24 times. 2 times, what am I doing? 2 times, sorry. 16, 4 is here. Bring another 0 down. 8 goes into 45 times. So 1 over 8 is equal to this particular decimal, 0.125. But it says if it's not repeating, I want you to round it to the nearest hundred. So that rounded to the nearest hundred is going to be 0.13. 4/5. 4/5, if you divide, 4 goes inside, 5 goes outside. 0, right? Because 5 does not go into 4, allows us to use the decimals. And 5 goes into 48 times. So that's a nice terminating decimal. 3/5. 3/5 is also going to be a nice terminating decimal. I'm not going to divide because it's just 0.6. 1/3. Now 1/3, and I'll do 1/3. 1/3 is going to be, well, 0 goes here, right? We're going to add a 0. 3 goes into 10 3 times, which is 9. 1 left over, add a 0, bring that down. And it's going to be 3, and notice that it's going to be 3. If I add a 0 again, it's going to be 3, 3, 3, 3, 3. So 1/3 as a decimal, well, it's going to be 0.33333, go on and on and on and on. Or with the bar notation, we're going to use 0.3 with the bar notation on top. That indicates that there are 3's repeating over and over again. 1/4. Okay, 1/4 is easy. So if you have 1/4 of something, think about money. If you have $1 and you split it into 4 parts, how much would it be? Everybody would get 25 cents. So 1/4 of $1 is 25 cents, or if you divide it, you would actually get 0.25. So I'm debating what to do with 2 sevenths on the test, because 2 sevenths is going to be a repeating decimal, okay? But it's not going to be, you're not going to find the repeating parts very early. The repeating part is going to come very late. It's going to take quite a few numbers. So I'm going to take this and do it over here. So I might just make this a nice special question. So here's 2 sevenths. 2 goes inside, 7. I need more room. So let me put it right here. 2. And notice that I'm making this really long. 7th, right? So 7 does not go into 2, add a 0, add a decimal. Let's start dividing. 2, which is 14. 6 left over, bring another 0 down. 7 goes into 68 times, which is 56. 4 left over, add a 0, bring it down. 7 goes to 40 5 times, which is 35. 5 left over, bring a 0 down. 7 goes into 50 7 times, which is 49. 1 left over, add a 0. 7 goes into 10 1 time, which is 7. 3 left over, add a 0. 7 goes into 30 4 times, which is 28. 2 left over, add a 0. Notice that this is going to be a repeat because 20 shows up again. 20 was the first 2 that we started with. So 7 goes into 20 2 times. So there's a 2. That 2 is going to repeat. So 7 goes to 20 4 times. 2 times 14. 6, right? 6 left over, bring a 0. Notice that again, we have this 6 repeating again and the 6. So if we continue, 7 goes into 28 times. Notice that the 28, 56 goes 4, and then it's going to be 2a. So 0.2857142. And starting from the 2 again, it starts repeating. 2, 8. The next number is going to be a 5, 7, 1, 4. And then it's going to be again 2, 8, 5, 7, 1, 4. And again 2, 8, 5, 7, 1, 4. So those 5 digits are going to be repeating. So 2 sevenths as a decimal is 0.2857114, and the bar notation goes over on top of these 6 numbers because those are the digits that are going to be repeating over and over forever and ever and ever. Okay, so that's the answer for 2 sevenths. And then we have 11. Explain how to find the opposite of 1. Really? The opposite of 1. Well, here's 1, and the opposite of 1, I'll draw number 1. Here's 0, here's 1, here's negative 1. So, if you're at 1 and I ask you to find the opposite of 1, you would go, well, that's easy. It's negative 1, so you land here. And then you're asked to take the opposite of that, right? Because you're taking the opposite of the opposite. So from negative 1, you go back to 1, because the opposite of negative 1 is 1. So, the opposite of 1 is negative 1. Okay, make sure you either use a diagram like this or you're able to explain using words. And opposite numbers always have the same absolute value. Is this statement always, never, or sometimes true? Opposite numbers always have the opposite value. Is this statement always, never? Okay, so let's pick an example. Negative 6, right? The opposite of negative 6 is 6. Would these two have the same absolute value? Well, the absolute value of negative 6 is 6 because it's 6 units away from 0. The absolute value of 6 is also 6 because it's also 6 units away from 0. So you pick any other 2 numbers, you'll notice that you have the same thing happening over and over. So in this case, that statement is always true because they're equally opposite numbers. Opposite numbers are equally distant from 0, right? They're same units away from 0. Opposite numbers will always be equally distant from 0. So that statement is always true. Okay. And I think this is it. No, yes, it is. Okay, so that's it for this one. Okay.